This video summarizes the technical proposals behind GreenDoop, the new distributed file system based on Haddop focused on energy saving for data centers. We are focused on data center infrastructures because they support cloud computing services and conform the basis of cloud services like Google, Amazon, or Facebook. The energy efficiency improvement is achieved by applying energy policies based on booting and switching off computers, reducing the number of machines and keeping the benefits of redundancy. Haddop is going to be our base system, a distributed file system led by Apache and based on Google File System. Our first proposal is to divide the data center in sectors. The number of sectors will match the number of copies we want to keep. In a Haddop system with 3 replicas, we will divide it in 3 sectors, one for the primary copy and the others for the other replicas. This distribution will follow Haddop's distribution policy. The goal here is to switch off as much full sectors as we can. Our second proposal is to modify the heartbeat system in order to be able to run a new command, switch off. When a node is switched off, it is stored in a list of switch off nodes. Our third proposal is about a group of buffer nodes. Its mission is to keep system consistency, storing the blocks that couldn't be stored in a machine that is switched off. Given a certain period of time, these machines will be booted and buffer blocks will be copied, keeping file system redundancy. Our fourth proposal is to modify the balancing policy of Haddop. From the original proposal of being distributed through several machines to our vision of filling every machine in order to be able to switch off machines that aren't being used. Our fifth proposal is to always leave a percentage of machines on. This way we can improve performance and availability of services. Our sixth proposal is to create a booting and switching off node that orchestrates all the modifications and policies. Given a set interval, it will run a decision algorithm that will switch off machines according to the following questions. Does it belong to the sectors that must be on? Are these blocks available in other machines? Can it be switched off maintaining the minimum percentage of machines on? It also manages the replication supported on buffer nodes and will put machines as needed in case of failure. In order to show these proposals in a simulated scenario, we have deployed a virtual data center of 1050 machines using a simulation tool developed by this team and called Datacenter 5000. Several simulations over a 6-month period have been run. In this simulation, the green areas mean that machines are on and available to give service to users. Meanwhile, gray areas represent switch-off machines. In the same manner, yellow means that machines are booting, and red means that machines are being switched off. This simulation is intended to leave permanently just one sector on. As we are simulating worst-case scenario, at this set period of time, it will put the other sectors fully and will make copies of all the data stored in the main sector or buffer nodes. Replication time is also a parameter of this simulation. In this case, we propose an interval of 3 minutes. Energy consumption for 6 months of our GreenDoop-based data center is about 180 megawatts versus the consumption of 360 megawatts of a traditional Haddop-based data center. That's 42% less of energy consumption. In 1 year, we could save up to 272 megawatts, 38,000 euros, and 63 tons of CO2. The popularization of GreenDoop-based data centers would benefit companies that manage world data centers, as these infrastructures consume 1.5% of the energy worldwide.